Hey guys, today we're going to take a look at 2.1, which is kind of getting into the basics of how we write and graph inequalities. Now, yesterday in class, I had you guys working on the Desmos exploration activity where you guys kind of played around with how the different points on the number line for that inequality would create the entire graph for it. Today we're going to get a little bit more specific with how those inequality symbols tell us what the graph should look like. So just to start with, just some basic definitions and how we define things, how we will say things based on what the inequality symbol is. Um, for our inequality, we know that's just a math sentence that contains one of the four following things. Could be less than, greater than, less than or equal to, or greater than or equal to. If it's got one of those four things in there, we call that an inequality. For a solution of an inequality, it's any value that makes my inequality true. Just like we defined our solutions last chapter for our equations, any single value that we can plug in for that variable that makes my equation true was a solution. Same idea here. It's just that our solutions now are going to be a huge range of numbers instead of just a single value. Because there's going to be a lot of things that could make this thing, our inequality, less than or greater than, whatever it is we're looking for. So for the following symbols, the order that they're written in, we always read it from left to right, just like we do a regular sentence. So if we're looking at this first symbol here, that is read as greater than. This next one would be then less than. Oops, not less than, less than. And that should be just because we know for inequality, it always opens up to the bigger thing or points to the smaller thing, depending on who your elementary teacher was. It might have been the monster, the alligator opens up and is hungry, so it wants the bigger thing, or, it points to the smaller one, but it's always going to be opening up to the bigger thing. So that first one, since it's opening up to our first part of that statement, that means that that first thing is bigger than or is greater than the second part. And then vice versa. For our second one here, for less than, it's pointing to the smaller one, opening up to the bigger one. So the thing that we're reading first is less than the thing that's on its right. When we add in the little line underneath it, that just also means or equal to. So this first one here is greater than or equal to. And that would mean this is also less than or equal to. And that just means we have both of those as options. Our number could be greater than the other one, or it could be exactly equal to the other one. So it just adds in some other options for us. This last one, the equal sign with a little slash through it, just like you would expect, that just means not equal to. And we'll use that occasionally, usually more so when we're checking solutions or when we're trying to find some different values that could be what we'll eventually call our border points or our boundary points. But just to establish again that symbol, we haven't used that explicitly. I haven't named that back in chapter 1, so we're just going to do that for this chapter. All right. So with an inequality, we have two different ways that we can graph them. We have an open circle and we have a closed circle. Because what you saw yesterday when you started filling in those points on the Desmos activity, if we were able to do this continuously and for every single option that is less than 3 or is greater than -1, we're going to just have a solid set of points going from left to right or from right to left, depending on which direction your inequality goes. But that boundary between where our solutions start and where our non-solutions start, or I guess where solutions start and end, that boundary is going to either be open or closed based on whether or not that endpoint can be included as a solution. So our two different inequality symbols that give us open circles would be just less than, would be just less than and greater than. With both of those, because we can't be equal to whatever that number is, we know that that number cannot be included in our solutions. which means less than or equal to and greater than or equal to are our two symbols that we do include that endpoint, because it could be bigger than that number or it could be exactly equal to that number. And hopefully that'll make a lot more sense once we get into the actual graphing side of things. When you see some examples, it'll become a whole lot more apparent for us. All right, so identifying solutions. When we're looking at identifying if something is a solution, just like we did if we were going to check our answer back in chapter 1, all we're doing is plugging those values in for x to see whether or not that inequality is true. So I'm going to do that with just a couple of these, not every single one of them, just because to save us some time here. So if I was going to check and see if -3 was a solution of x is less than or equal to 2, what I would do is take this -3 and I'm going to plug it in for x. And I'm going to ask myself, is that inequality true? Is -3 less than 2 or -3 is equal to 2? If either of those two things are true, that means -3 is a solution of that inequality. And in this case, -3 is smaller than 2, right? It's further to the left on the number line. So -3 is a solution. I could check the same thing with my other ones. 0 is also less than -2, so that is another one of my solutions that is true. As soon as we get to this last one, 4.5, if we were to plug that into our inequality, 4.5 is supposed to be less than or equal to 2. We'd know it's definitely not equal to 2 because it's not 2, but 4.5 is also bigger than 2, so it's not less than. So this would not be a solution. So in this case, -3 and 0 would be my two solutions. In this next one, go ahead and try it on your own and pause the video here, see if you guys can figure out which of these three are solutions and which ones are not solutions to the inequality m is greater than -3. Okay. Hopefully you took a look and saw that in this case, -8 is not a solution, but -2 and 1.4 are solutions, because those two numbers are bigger than -3, right? They're further to the right on the number line. But -8, even though the 8 is bigger than the 3, because they're both negative, -8 is actually a smaller number in comparison than -3 is. All right, so into graphing. Now, when we graph, I have maybe some different expectations than what some of your other teachers might have had in the past. When I have you guys graph something on the number line, so we'll just say, when graphing on the number line, you must include at least 5 values. So you can include more than that, but at minimum, I want 5 numbers on your number line. You can see I provide a whole lot more than that on the number line that's printed on the page here, but at minimum, I want you guys to at least include 5 of them. So when we're going through and graphing these, x is greater than -2. That number that my x is related to, that's my boundary between where I have my solutions and my non-solutions. So the way I'm going to set my number line up, I'm just going to put -2 in the center, because I know that's going to be where that change happens from answers to non-answers, solutions to non-solutions. If I want 5 values on that number line, my next two biggest numbers from -2 would be -1 and 0. The next two numbers smallest would be -3 and -4. So at minimum, I should include that. If I'm going to graph this boundary then, if I'm going to talk about all of the x values that are bigger than -2, that's going to be all of these values over here to the right. Now, there's a lot of different ways that you can indicate this. I'm going to show you how I do it, not using the squiggly highlighter. But the way that I do this, at the boundary, so at that number where it changes from answers to non-answers, you're going to put a circle. This is where that open and closed circle comes into play. Because here in this case, since x is just greater than -2, Negative 2 is not one of my solutions. So that can't be shaded in. Negative 2 is not an answer to this inequality. So I'm going to leave it as an open circle here. And then since I want everything to the right of that shaded, this is where you have the different options. And it's personal preference, and it kind of depends on what writing utensil you usually use. I am one who usually is just using a single colored pen or pencil. So just to kind of emphasize where it's going, I actually usually do this little like up and over arrow to indicate that this is the direction that I want everything shaded in. You could also, if you're a squiggly person and you like shading stuff in and you want to say, all right, all of this stuff in this direction, or if you are a highlighter person, you like using different colors, you could also just say, ooh, look at all that. All of that side of my number line is shaded. I don't care how you go about showing which side is shaded, if you're an arrow person, if you're a squiggle person, if you're a color person, but what does have to happen is you have to have that boundary with either a very obvious open or closed circle, and then you also have to have the arrow on which side, so I know that you know it continues on beyond that. Because eventually we'll get to some where you might have two boundaries, where you have an open circle on one end, a closed circle on the other end, and you're just shading in between the two of them. All right, so taking a look at B, if I'm going to do this, the more you do these, the easier they will become. So we want 7 as my boundary. The next two biggest numbers would be 6 and 5. Nope, I'm going positive now. Would be 8 and 9. The next smallest number would be 6 and 5. My boundary happens at 7. In this case, it is an or equal to, so now I get to go ahead and shade in that circle. It's going to be a solid circle there because it's closed, because 7 is one of my solutions because it's or equal to. So in this one, we want all of my y values to be less than 7, which would be all of the left side of my inequality. So what I'm going to do that is just go up and over, and I'm done. That's it. Part C and D are a little tricky just because you have to be careful because of the order that they're written in. 2 is still my boundary, so I'm still going to start 2 here. 3, 4, 1, 0 would be my middle 5. This boundary still happens at 2, and it is still a closed circle because you are dealing with or equal to. But which direction it goes, you have to be careful with. You have two different options on how to do this. You could still picture what values of G would make that inequality true, which in this case, G has to be bigger than my positive 2. So that's going to be this direction over here. Right? 3 would make that inequality true. 4 would make that inequality true. 5 would make that inequality true. So that's the direction that your graph should be shaded. Your other option on how to handle these, like if we do this with number 6, what you are allowed to do is to flip the inequality around. But what you have to be careful of is after you flip it, so the variable's on the left, if that makes you more comfortable, you just have to make sure it's still pointing and opening to the same things. So if I wanted to rearrange this, I could put this as B and -6 here. But when I do that, I still have to make sure that B is being pointed to by my inequality. So in this case, B is less than -6. The reason that I would want to do this is because of a shortcut I'm about to show you. If you didn't notice, on the first 2 that we did with number 3, part A and part B, when your variable is on the left side of your inequality, the direction that your inequality points is the direction that you should be shading. So if we look at part A here, my inequality was greater than, but that arrow points to the right, and I shaded the right side of my graph. In part B, we had y is less than or equal to 7, so you can see this inequality points to the left, and I shaded my graph to the left. So that trick works if you have your variable on the left side of your inequality. So here, after we rearrange D, so that now it's B is less than -6, I'm still going to set up -6 here in the center, with -5, -4 being bigger than it, -7, -8 being smaller than that. It is still an open circle since it's just less than. But now again, without having to really think about what values are bigger than or smaller than -6, I see that this inequality here is pointing to the left. So I'm going to shade to the left. And that's it. Now that trick is really, really helpful because the next thing we have to do is be able to write our inequalities from a graph. Now these, you can use whatever variable you want. If you want to change it up and always, use something different, feel free to do so. Me personally, I usually just default to X because that's just pretty standard for using variables. When you do this, again, be strategic. You get to choose how you want to format it. I always put my X on the left side. I put the boundary that it happens at. So in this case, you can see my open circle is at -5. And this is where you can use that shortcut. You see that the right side of your graph should be shaded. So I'm just going to make that arrow point the same direction that my shading happened. That will make your inequality true. In this case, the last thing we need to check on is just whether or not it should be a greater than or a greater than or equal to. And that's based on the circle. If it's an open circle, it stays as is. If it's a closed circle, you have to add that little line to make it a less than or a greater than symbol. But here, this is an open circle, so it stays as just greater than, and that's my answer. X is greater than -5. If we look at part B for this same section, now my boundary is happening at +4. I'm still going to have my X on the left, my boundary, my number on the right side. Here my shading was to the left, so I'm going to point it to the left. But you can see here my circle was closed, so I'm going to add that or equal to underneath because that fills in that circle. That's what that line means. All right, just a couple more. For part C, this is the last graphing one. Go ahead and try this one on your own. So here we've got -1 as my boundary. It is a shaded in circle. So go ahead and try on your own what that inequality would look like. Pause the video and then play as soon as you're ready. All right, so let's take a look. Here, X and -1 are my two boundary points. It is pointing to the right, so I'm going to be pointing to the right. It is a shaded in circle, so or equal to. All right, for the last section here, we're getting into some application problems, so now some word problems. And this is where the more practice you do with this and the more acquainted you are with the different words that we use to describe the different inequality symbols, it'll become easier for you the more you practice it. So the way that we're going to be doing these, you get to pick your variable in most cases. Sometimes it tells you what I want you to use, or the book tells you what it wants you to use for the variable, but you're just trying to figure out how they relate to each other. So in this case, for part A, to be labeled a sugar-free food, a food product must contain less than 0.5 grams of sugar per serving. So important information here. Obviously, 0.5 is going to be our boundary. That's going to be our dividing spot or dividing point from where it can be considered sugar-free versus not sugar-free. But what we are also going to be focused on is trying to find these phrases in here that tell us how it relates to that boundary. In this case, sometimes it'll just say exactly as we're used to seeing it, less than, greater than, less than or equal to, or greater than or equal to. If that's the case, awesome, we're happy because we know that the amount of sugar in our food has to be less than 0.5. And that's it. Sugar has to be less than 0.5 in order to be considered sugar-free. That's all we have to do. That's not always the case because you can see this next one. A doctor has earned more than $50,000 since being hired. So in this case, obviously $50,000, that's our money value. That's that number that we're going to use for our boundary. But more than isn't exactly greater than, but we know that more and greater are the same. They're synonyms, right? They mean the same thing. If I've earned more than $50,000, that's the same thing as earning greater than $50,000. So whatever variable you want to use, D for doctor, S for salary, D for dollars, whatever you want to use. I'm just going to use D because that could be dollars or doctor's salary. We know that has to be greater than 50,000 in order for that to be true. And again, it's all just in relation to how those symbols are arranged. You want that salary to be more than 50,000, so that's why it opens up to your variable. All right, these last two are the most confusing. We start adding in different phrases where it's not just greater than, less than, more than, fewer than, stuff like that. That's more obvious. Part C is the restaurant can seat at most 150 people. So we see 150, that's going to be our number. Let's just use R for what our restaurant can seat. So we know that R and 150 are going to be related to each other in some way. Some inequality is going to be true with that statement. So what you could do is play around with the different inequalities and see if it makes sense. We know that if the restaurant can seat at most 150 people, we're okay, right? The restaurant's okay if they seat 100 people, right? Or 50 people, or 10 people. We're okay with that R value being less than 150, but we're not okay, right? The restaurant would get in trouble if they were seating over 150 people. So in this case, the less than is what that kind of relationship is. But it tells us that we can seat at most 150 people. So in this case, we would be okay, the restaurant would be allowed to have exactly 150 people. So we have to add in this or equal to in order for that to still remain true. So any R value that's 150 or less is fine, is allowed based on the rules. So R is less than or equal to 150. For part D, it's kind of the flip side of this. In this case, a person must be at least 16 years old, at least 16 years old in order to drive. So let's just say Y is how many years old they are. In this case, how it relates to 16, you are able to get your driver's license, you're allowed to drive if you're greater than 16 or if you are exactly equal to 16. But we couldn't have it be the other way around. Legally, we couldn't drive before we were 16 years old. So that Y value that represents how many years old we are has to be 16 or bigger. So that's where that at least comes from. So at least and at most, those are both or equal to situations. And again, just make sure you guys are playing around with getting used to how those things work. The more times you see them, the easier they will become. That's all I got for you today. Homework is down here at the bottom. It's page 58 and 59, 16 through 36, and 42 through 46 evens. So that's basically all the evens from 16 to 46, but skipping number 38 and number 40. But it's all, again, just evens for all of those. Now that you're done watching that, go ahead and give the homework a shot. Let me know if you have any questions while you're working. Otherwise, have a fantastic day, and I'll see you guys tomorrow.